All right, your next concept in Unit 7 stoichiometry is learning how to do a mass-to-mass stoichiometry problem. So in this problem, we are given a gram quantity of one of the substances, could be a reactant or product, let's call it A, and we're based on the chemical reaction that A reacts with, we're going to be able to predict the amount of grams of another substance, either reactant or product, in the chemical equation by doing mass-to-mass stoichiometry. Now, the great thing about this is all of the pieces in order to do this problem have already been learned. Okay? We are going to need to make use of molar mass, which was learned in the last unit, and the mole ratio. It's the mole ratio that allows me to convert amount of A to amount of B. And therefore, in order to have a mole ratio, we need a balanced equation. So in all these problems that I'm going to work through with you today, the first step is to get the balanced equation so we can utilize the mole ratio to do the stoichiometry. All right? So down here we have, this is a very important framework. It's something that you are going to want to have access to whenever you do a problem. So if I'm starting from grams of A and asked to figure out grams of something else, this is a three-step stoichiometry problem. So that means I'm going to need to have three conversion factors. The first conversion factor, we're converting mass of A to moles of A. In order to convert mass to moles, we need the molar mass of the chemical compound. That's one conversion factor. That is something you learned how to do last unit, and it was on your test to do a mass to mole problem. And just about everybody got that problem right on the test. The next step is what we learned the last lecture, which is to go from moles of A to moles of B. And you'll notice this is the step that I'm able to convert from one substance to another substance. I need the mole ratio to be able to do this. When I look at a chemical reaction, the coefficients link one substance to another in a balanced equation. That's a mole ratio. It is not a mass ratio. And this is why I've got to first convert to moles before I can use the ratio. Then, after step 2, I have now moles of the new material. Lastly, to convert that into grams, I do the repeat of step 1, but now it's backwards, so the conversion factor will be opposite, where I'm now able to use the molar mass of compound B to convert its mole quantity to its mass quantity. And that is how you do a mass-to-mass problem. All right, so let's go ahead and do our first example. How many grams of potassium chloride will it take to produce 50 grams of oxygen when it decomposes? So potassium chlorate is going to decompose, producing oxygen. What is the second product? Now, many of you probably would struggle with this because I have not asked you to predict products. So on the test, I'm going to give you the word equation of the substances. The second product is potassium chloride. All right, real quickly, I'm going to pause the lecture. Please balance this equation and see what you get. All right, you should have gotten 2, 3, and 2. All right, now we are starting with grams of oxygen and we are asked to figure out grams of potassium chlorate. So right away I identify that this is a mass to mass problem. Okay, so right away I know it's 3 steps. First step is you write down the given number. Okay. I immediately know it's 3 conversion factors whenever it's a mass-to-mass problem, and now I start working with it. Okay, the first thing is whatever unit we start with, like always, that unit's going to go on the bottom. Now, in the framework, I'm going from grams of A to moles of A. So whatever I'm going to, that's the unit that's going to go on the top. So I'm converting grams of oxygen into moles of oxygen. Now, what allows me to convert that is the molar mass of oxygen. So real quickly, what is the molar mass of O2? Now, you don't have to show the math for this, but you should know that oxygen has got a molar mass of 16, but that's when it's just a single O. For 2 oxygens, it's 32. 1 mole of oxygen weighs or has a mass of 32 grams. The grams of oxygen would cancel. And if I were to stop here, this would give me the moles of oxygen, but I don't want that, all right? So the next step is now to go from moles of A to moles of B. So whatever's on top becomes the next thing on the bottom. Apologize, there was an announcement on the school web. All right, so now I'm going to go from moles of A, the oxygen, into moles of B. So who is the new substance I want to figure out? The potassium chlorate. So the second step is the mole ratio, exactly what you did in the last lecture. So whatever mole quantity we have, we're going to get rid of it by going to the next mole quantity. Now, where do the numbers in the mole ratio come from? If you can remember back to the last lecture. The balanced equation. This is why we need the balanced equation. There's a 2 in front of the potassium chlorate, so I'm going to make sure to match it up with the potassium chlorate, and there's a 3 in front of the oxygen. Now the moles of oxygen cancel. If I were to stop here, this would give me the moles of potassium chlorate, but I don't want moles, I want grams. So then again, whatever unit is on top becomes the next unit on the bottom. So again, to do this last step, I need to know the molar mass of potassium chlorate. So I need to take out my calculator and add up the mass of 1 potassium plus 1 chlorine plus 3 oxygens. You do not need to show me the full level of work for this, but you do need to show me the conversion factor. The molar mass of potassium chloride is 122.55 grams per mole. So 122.55 per 1 mole. Again, whenever I use molar mass is defined as the mass of 1 mole. So in steps 1 and 3, I'm always going to have 1 mole. I do not concern myself that there's a 3 in front of the oxygen because I've already utilized the 3 once in the mole ratio. In the molar mass steps of steps 1 and 3, we are always going to put down the mass of just 1 mole. It's the mole ratio. The mole ratio is the only time that we use the coefficients of the balanced equation. All right, now we have our mathematical work. Again, the moles of potassium chloride will cancel, and this will give me my answer of potassium chloride. All right, so let's go ahead and jump to the work. 50 divided by 32 times 2 divided by 3 times 122.55. And we get an answer of 127.66 grams of potassium chlorate. So that is how you do a mass-to-mass problem. All right? Now, I've shown you now how to do 2 mass-to-mass problems, and the homework has quite a few of those examples, but there's also a couple other variations of that. And I'm going to show you 2 examples of that to round off this lecture. The first one is here. How many moles of zinc is required to produce 100 grams of hydrogen when zinc reacts with hydrochloric acid? All right, so again, whenever I have been given a quantity of one thing, and I want to figure out a quantity of something else, this is stoichiometry. When I'm going to go from grams or moles of one thing to grams or moles of something else. So again, I need the balanced equation. But this is not a mass-to-mass problem. I'm starting with grams of A, which in this case is hydrogen, and I'm not being asked the amount of grams of zinc, but I'm asked to figure out the moles of zinc, which would be the moles of B. So we are not going to need to do all 3 steps. If I look back at my framework here, erase some of the stuff so you can see it more easily. I'm starting with mass of one thing, and I'm going to moles of something else. So that is not 1 step, but that's going to be 2 steps here. Okay? So 100 grams, I'll write down that value. And in a gram to mole problem, I only need 2 conversion factors. Okay, the first conversion factor is still the same. To go from grams of A to moles of A, I need to know the molar mass. Again, whatever unit I start with becomes the unit that goes on the bottom. Again, the molar mass step always is the mass of 1 mole. So I need to double the mass of hydrogen. And I always round hydrogen to 1.01. I know that your periodic table it shows 1.008, but I'm just going to go to 1.01. Okay. And then the next step is to go from moles of A to moles of B, which is the mole ratio. So again, the moles of hydrogen go down, get rid of it, and the moles of zinc, which is what I want, goes on top. In order to do this, I need the balanced equation, which I forgot to do. So zinc reacts with hydrochloric acid. Again, I would give you the formulas of these on the test. Produces zinc chloride and hydrogen gas. So there would be a 2 here in front of the HCl. So here's the chemical reaction of zinc reacting with hydrochloric acid to form zinc chloride and hydrogen gas. Okay, the mole ratio of hydrogen to zinc, you'll notice there's no coefficients in front of either of them, so it's a 1-to-1 ratio. So 100 divided by 2.02 gets us 49.5 moles of zinc. So we literally do a mass-to-mass problem, but we just stop after step 2. Okay? And that's how you do a mass-to-mole problem. Framework, I don't need to worry about step 1 because I'm already starting here. I'm starting with the moles of something, and I'm being asked to figure out the mass of something else. Again, that means I'm going to need 2 steps. So if I have mass to mole or mole in my framework, in a mole to mass problem, the first step is the coefficients, the mole ratio. I'm going to turn the page here. Problem number 5. Real quickly, I'm going to pause the lecture. I'm going to do this problem after I pause it, and I'd like you to give this one a try. All right. The reaction for this, we're going to make water, so this is going to be hydrogen plus oxygen produces water. So the first thing I want you to do is balance this equation, and I would like you to go ahead and do, again, this is a mass to mass problem. So it's going to be 3 steps. Go ahead and do it, give it a try, and then when you start the lecture up, you're going to see the answer to see if you got it correct. All right, you can see the work here. First of all, the balance equation, we have 2, 1, 2. The first step always is we divide by the molar mass of water, which is the mass of 1 mole. Again, the moles of water will go on the bottom because it's the one that we are getting rid of, and we're going to the oxygen. And that ratio is 1 oxygen to 2 waters, 1 to 2. And the molar mass of oxygen, O2, again, oxygen is diatomic, so the molar mass is not 16 but 32. And so in your calculator, it should be 54 divided by 18.02 divided by 2 times 32, and we get our answer of 47.9 grams of oxygen. So that, again, is a mass-to-mass problem. If you can do mass-to-mass problems, the test is going to be quite easy because you're going to do quite a few of these as you go through the different individual problems. All right? All right. The last type of problem that I have for you is a mole-to-mass problem. So now if I look back at my mass, this is going to require 2 steps. So it says how many grams of oxygen are required to unite with iron to form iron 3 oxide. So oxygen is reacting with iron to produce iron 3 oxide. Again, in this lecture, if ever all you want to stop the lecture and see if you can try to do the problem on your own, please do. But I'm going to go through this problem in entirety. So there's 2 irons here. There's only 1 here, so I need to put a 2 there. There's 2 oxygens and there's 3 oxygens. So I need to make them both be 6. 3 times 2, 2 times 3. But putting that 2 there changes the number of iron from 2 to 4. So my coefficients are 3, 4, and 2. All right, I always write down the given amount. And as I said, a mole to mass problem is going to be 2 steps. So I already know the moles of iron, so I don't need the molar mass. The purpose of the molar mass is to convert the grams to moles, but I already have it. So whatever unit is I start with is what I put in the bottom. And I'm going from iron to oxygen. Okay? The mole ratio there is there's 4 iron to every 3 oxygens. And then The last step is to convert the moles into grams. So again, whatever unit is on top is the next unit on the bottom. Again, the molar mass of oxygen, as we've done many times already, is 32 because it's diatomic. The moles of oxygen cancel, and that leaves me the answer of oxygen. So 1.4 times 3 divided by 4 times 32 gives me an answer of 33.6 grams of oxygen. So now I have shown you all the different types of stoichiometry problems that you can do. A mole-to-mole problem is what we did last lecture, which is one step. A mass-to-mass problem, which is 3 steps. A mole-to-mass or a mass-to-mole, both of these are 2 steps. So now you have an example or many examples of each of these types of problems that you can now look back at as you go through the homework. Your homework now is pages 7, 8, and 9. I would like you to do the odd ones, but the answer key in Canvas will be all of them, but there's quite a few problems there. If you feel like you only need to do the odds and have enough practice there, that should be good to go. If you want more practice, then do all of those problems. But all the answers will be supplied in Canvas. If you have any questions on this stuff, reach out to me. But your quiz now, which will be open on Friday, will be both last lecture and this lecture. Can you do all of these different type of stoichiometry problems? And that is what you'll be asked to do. Anywhere from 1 step mole-to-mole problems all the way to 3 steps where you have a mass-to-mass problem. All right? Again, if there's any questions, so reach out to me. Otherwise, hopefully this is something that with a little bit of work will make sense and will be a concept that you'll have with you for years to come. Okay? Thanks again for listening.